In episode 68, titled Consolidate Systems and Application Security Best Practices, we promise a cohesive checklist that ties platform safeguards, application discipline, and operational routines into one flowing practice you can actually run. The aim is clarity over cleverness, a compact set of behaviors that lowers risk without slowing delivery, with receipts that prove what happened and why. Think of it as a single spine that runs from identity to code to runtime to incident handling, so a change in one place is reflected everywhere it matters. When this spine is present, teams stop arguing taste and start shipping with the same guardrails, and auditors encounter the same evidence regardless of which service or system they open first. Identity is the first control plane, so enforce the basics the same way at every tier. Strong authentication, least privilege, and clean session hygiene that does not linger beyond need. Strong authentication means phishing-resistant factors for humans, short-lived workload identities for services, and no standing administrator accounts outside break-glass paths. Least privilege is not a vibe, it is specific roles with scopes and time bounds, plus approvals that leave an artifact you can show later. Session hygiene expires tokens on explicit schedules, rotates them on sensitive actions, and revokes them on device or posture changes. When identity reads the same in consoles, in applications, and in operational runbooks, access reviews become straightforward and privilege creep has nowhere to hide. Secure configuration turns intent into repeatable reality. Start with golden baselines for operating systems, container images, databases, gateways, and build agents that name the exact services, ports, cryptographic settings, and logging destinations you expect. Add drift detection that compares running state to the baseline on a schedule and deployment, and treat differences as work, not surprises. Controlled change is the final leg. Pull requests, peer review, and small, tested updates that carry their own rollback plan. The test of maturity is simple and ruthless. On any ordinary day, could a new engineer read the baseline, compare it to a host, and tell you what changed and why without a scavenger hunt? When the answer is yes, resilience moves from hope to habit. Keeping software current is a discipline with 4 parts that reinforce each other: dependency pinning, software composition analysis, patch service level agreements, and safe rollout rings. Pinning freezes direct and transitive versions so builds are reproducible and diffs are real. Software composition analysis, spelled SCA, inventories components, flags vulnerabilities, and maps licenses so you know what you ship. Patch service level agreements, spelled SLAs, name the windows for critical, high, and moderate fixes with owners who can accept or escalate. And rollout rings move changes from canary to cohort to fleet with measured gates. This rhythm beats back surprise and lowers blast radius, because code moves when you say so, and not when a registry happens to update underneath you. Secrets belong in vaults, not in code or configuration files, and their lifetimes should be short enough to be boring. A managed secret store issues credentials on demand to identities that prove themselves, rotates them automatically, and records every retrieval with time, actor, and purpose. Short-lived tokens replace long-lived passwords. Client libraries fetch at runtime, and plain text never lands in repositories, image layers, or environment snapshots. For humans, elevation is time-boxed and ticketed. For services, the platform injects secrets at start and refreshes on schedule. The artifact that matters is the access log, a terse record that shows exactly who obtained what, when, and from which workload or console. When secrets move this way, leaks become rare and containable. Telemetry is your memory, so instrument it from the start with structured logs, metrics, and traces that share accurate time and honor privacy. Structured logs carry fields for identity, request identifiers, data classification, and zone, so searches become answers rather than archaeology. Metrics expose service-level objectives and resource health, while traces stitch hops together into a single, navigable narrative across services. Accurate time comes from trusted sources, not ad hoc clocks, and privacy controls mask or tokenize sensitive fields before they leave the process. The result is a stream of signals that humans and machines can both understand, which shortens incidents, strengthens reviews, and lets you prove behaviors without touching production boxes. Releases pass through gates because haste and safety can cooperate when checks are automatic. Your continuous integration and continuous delivery pipeline, spelled CI/CD, runs linters, unit and integration tests, and security analyzers every time code moves. Static analysis, SAST, catches risky patterns in code. Dynamic analysis, DAST, probes running artifacts in a staging environment. And approvals tie a human acknowledgement to high-impact changes with context. Promotion happens only when each gate emits receipts stored alongside the commit and build artifacts. And rollbacks are one command because the pipeline kept what it needs. This is not ceremony. It is how you ensure the same rules apply to the 10-line fix and the 1,000-line refactor. Networks and services deserve segmentation that matches business intent rather than convenience. Minimal routes let only named parties talk, and service identity replaces brittle addresses so policies follow workloads rather than hosts. East-west policies restrict which tiers can exchange traffic, and north-south edges prefer allow list egress through proxies and private endpoints rather than a wide-open internet. Observability reinforces design. Flow logs and denial counters tell you when attempts stray outside the map, which is either a bug to fix or an attack to contain. Over time, this turns flat networks into well-described hallways, and lateral movement becomes noisy and expensive instead of casual and cheap. Data safety means classification, encryption, and lifecycle rules that reflect law and business rather than habit. Classification labels tie to concrete handling, which datasets must encrypt at rest with customer-managed keys, which require mutual transport layer security in transit, and which can move only between specific regions. Lifecycle policies enforce retention windows, legal holds, and deletion with verification artifacts that attach to tickets and audits. Access reviews check who can read, write, export, and delete, and they run on a schedule with real owners and deadlines. When these pieces align, privacy and compliance stop being abstract promises and become settings, jobs, and receipts that hold up in the meeting that matters. Resilience is built, not wished. So pair backups, health checks, auto-scaling, and circuit breakers with tests that simulate stress. Backups include application-consistent snapshots, off-account or off-region copies, and periodic restores that measure recovery time objective and recovery point objective against the numbers you promised. Health checks watch real dependencies and escalate in time to reroute, and auto-scaling matches observed demand with guardrails that protect budgets and limits. Circuit breakers degrade gracefully when upstreams falter, returning clear responses while the system sheds load. Together, these keep customer experience coherent on a bad day and give engineers the headroom to repair without improvising under fire. Incidents feel chaotic only when playbooks are absent. Prepare service-specific runbooks with clear triggers, alerts, thresholds, and anomalies, plus the artifacts to capture and the rollback procedures to execute. Triggers connect to evidence, logs, traces, packet captures, configuration diffs, and ticket links with timestamps and owners. Rollback is reversible and practiced. Isolation leaves room for diagnostics, and communication follows a short script that sets expectations internally and, when needed, externally. Afterward, reviews capture a small set of improvements to code, configuration, or monitoring, and they assign dates and names so learning sticks. This discipline replaces folklore with muscle memory. A small scenario shows the spine doing its job without heroics. A team ships a minor feature flag to expose an additional field in response. The pull request triggers linting and unit tests. The pipeline runs static checks and a tiny dynamic probe in staging. Secrets do not change because the service uses runtime injection. And the deploy goes to a canary ring with traces sampling a little heavier. An input validation error appears in staging logs because a partner sends an unexpected character. Server-side checks reject it with a stable code. Metrics register a small blip, and error messages stay generic while traces carry the details. The team adjusts the validator, repeats the gates, and promotes to production with auto-scaling ready and circuit breakers quiet. Nothing broke, everything learned, receipts collected themselves. We close by directing one practical step that makes this episode real. Draft a one-page best practice sheet tailored to a current application. List its identity model and roles, the baselines it inherits, the dependency and patch cadence it follows, the validation and encoding rules it uses, the vault paths for its secrets, the telemetry fields it emits, the exact CI/CD gates it passes, the segments it resides in with egress allows, the data classes it touches with key references, the resilience knobs it relies on, and the incident triggers and rollbacks defined for it. Keep the language plain and pair each claim with where to find the artifact that proves it. Post the sheet in the repository and revisit it at each release. When this page exists, the checklist stops being theory and becomes the way your team ships safely, quickly, and with confidence. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.